This video will cover section 1.7 on inequalities, and in this section we're only going to discuss linear inequalities. So if you go to do your homework and there are any that are quadratic where they have x squared, you can just ignore those. So we're only doing linear inequalities. Alright, so linear inequalities have multiple solutions, unlike equations which usually only have one. Alright. Now, if you'll look on page 147 in your textbook, there's a chart that describes how we're going to write these multiple solutions. So if you ever get confused, go back to page 147, right, and there's a chart there. Now, to solve linear inequalities, we do it in the same manner as linear equations with one exception, and that exception is when you divide or multiply by a negative, you have to reverse the inequality symbol. And when I say divide by, this is dividing by a negative. This is when I would reverse the inequality. If I'm doing this, this is dividing into a negative, and I'm dividing by a positive number. Here I would not reverse the inequality symbol. Here I would reverse it because I am dividing by a negative. Alright, so make sure you understand the terminology, the wording. By and into, alright, are different things. So make sure you're dividing by a negative, and that's going to be these two versions here. Alright, now, whenever you finish solving the inequality, your solution is going to look something similar to this. It's either going to be less than, greater than, less than or equal to, or greater than or equal to. And there are two additional ways in which we can write those answers. One of those ways is to graph it by using a number line. The second way is to write it using interval notation, and that's where we put the smallest value up to the largest value, and all the solutions can be found somewhere in that interval or between those small and largest values. Alright, so if I want to graph, we're going to look at these three solutions. Alright, and I want to put them all on a number line. Alright, so to graph using a number line, you don't have to be very detailed. Just make you a number line, and it can be as long or as short as you want it to be. And just somewhere on that number line, it doesn't matter where, you're going to place what you say is the solution. Alright, so this says x is less than 3, so somewhere on my number line, I'm going to mark the number 3. Now, it doesn't matter where on the number line, as long as you get that 3 on there. Alright, and so what I want to show is that all the values that are less than 3 are solutions to my inequality. So any number that is less than 3. And there are an infinite amount of numbers less than 3. I can continue in the negative direction forever. Alright, and I want to show that on the number line. So I'm going to shade, remember on the number line, before I shade. Remember on the number line that as you move to the left, the values get smaller, and as you move to the right, the numbers get larger. So as we move to the left, because we're looking for things smaller than 3, alright, we can continue on in the left direction forever. Well, you don't want to keep drawing a line forever, so we put this arrow at the end, and that indicates that it continues on. And this arrow is going to represent our negative infinity. Alright, now, somehow we need to say where we're going to end and what values are included. Now, we're looking for anything smaller than 3, but we don't want 3 to be seen as a solution. So the way that we do that is we put a parenthesis on the 3. And that parenthesis indicates that 3 is not a solution, but anything less than 3 is a solution. So you're probably used to doing open circles and closed circles. So we're not going to be doing those. Alright, the open circle and the parenthesis kind of go together, and then I'll show you what the closed circle goes with. But we're not using circles anymore because when we write interval notation, we don't use circles. So we want to keep things looking the same. Alright, so there is the graph. Now, if I want to write this same set of solutions, but now in interval notation, I'm always going to start with the smallest value, a comma, the largest value. And I know that anything in between those two values is a solution. All right, so if I'm writing an interval notation, the thing that occurs first on my number line is what should occur first in my interval notation. So when I look at my number line, always reading from left to right, the thing shaded furthest to the left, or the smallest thing that's shaded, is negative infinity. So that should be the first item in my interval notation. Now, with infinity, you always use a parenthesis. Alright, then we're going to do comma. And if I follow my number line up to where my shading ends, it ends at 3. But we know 3 is not included, so I'm going to put parenthesis there. Alright, now I want to do the same thing here for x is greater than 3. I'm looking for all the values or solutions that are greater than 3. That is what will make my inequality a true statement. So I'm going to draw me a number line. Somewhere on there, I'm going to mark a 3. It doesn't matter where. Alright, and then I want to know all the numbers bigger than 3. So to go bigger, I move to the right. So I'm going to shade all the numbers to the right. Alright, I don't want to include 3. I just want everything bigger than 3. So I'm going to put me a parenthesis on 3. To write that in interval notation, the smallest value I have shaded is a 3. And it has a parenthesis on it. And if I follow my shading until it ends at positive infinity. That's what this arrow represents, as positive infinity. Infinities always open and close with the parenthesis. They never have the bracket on them. Alright, now these two are less than or greater than, but they also include the little line under there, which means equal to. So x can be less than 3 or x can be equal to 3, is what that means. Alright, I want to show that on my number line. So I want to draw me just a basic number line, somewhere on it mark a 3. I want to show all the values less than 3. We know to go less, we move in the left direction. And then the equal to part says that 3 is a solution. Alright, so to indicate that 3 is a solution, to include it, I'm going to use a bracket. Alright, and the bracket goes with the closed circle. Okay? Now, if I write this in interval notation, the smallest value I have shaded is negative infinity. Always put a parenthesis on the infinity. And I shade all the way up to the number 3, which has a bracket on it. So my 3 gets a bracket. Alright, if I have x is greater than or equal to 3, that means x can be greater than 3, or x can equal 3. I want to show that on my number line, so I draw it, mark a 3, and then greater than is to the right. I'm getting bigger, moving to the right. Alright, and I continue on forever, shading my arrow. Alright, and then the equal to part is indicated by the bracket. So I put a bracket on 3 to say include 3 as part of the solutions. Now when I write that in interval notation, I'll have bracket 3, comma, up to infinity parenthesis. Alright, now let's look at a couple of examples here. Let's take some inequalities and solve them, graph them, and write our solutions in interval notation. Alright, so here's my inequality symbol. Alright, if I'm solving, the inequality symbol works similar to the equal sign, in that negative 2x plus 7 is on the left, negative 5 is on the right. Alright, this is linear, so I want to subtract 7. That'll give me negative 2x is less than negative 12. I want to get x by itself, so I divide by negative 2. Alright, that leaves me x. Now I have divided by a negative. That means this less than now becomes greater than. And negative 12 divided by negative 2 is 6. Alright, so this says any solution for this inequality here has to be greater than 6. So pick you a number greater than 6 and fill it in and make sure that that makes a true statement. Now I want to show this on my number line. Draw me a basic number line, mark a 6 somewhere on there. I want all the values that are greater than 6, that is to the right. So I shade to the right. And then I have to know what to do with the 6. Am I going to include the 6, or am I just looking for things bigger than 6? Since there is no line under there, we don't include 6. So 6 gets a parenthesis. Now when I write my interval notation, it should match the shading on my number line. So wherever my graph starts is where my interval notation should start. I start shading at 6, and I go into positive infinity. Okay, let's try this one. So we have 3 plus 4x is less than or equal to 2x plus 8. I want to get my variable terms on one side, my constant terms on the other. So I'm going to subtract 2x. That'll give me 3 plus 2x is less than or equal to 8. Then I'm going to subtract 3. And that will give me 2x is less than or equal to 5. I'm going to divide both sides by 2. And I find that x can be any value that is less than 5/2 or equal to 5/2. Alright, so if I put that on a number line, draw me a basic number line, mark 5/2 on it. Alright, and so I'm looking for everything that is less than 5/2. So less than, getting smaller, would mean I shade to the left. Alright, so I've shaded everything to the left that's smaller than 5/2. Now I also want to say, show how it's equal to 5/2. So I'm going to put a bracket to indicate include 5/2 in my solution set. Now if I want to write an interval notation, it should match my graph. So the thing shaded furthest to the left, or the smallest thing that's shaded, is negative infinity, and I go up to 5/2. Infinities always get a parenthesis, and then since there's a bracket on 5/2, I'm going to put a bracket on the 5/2 in my interval notation.